For today's lesson, we're going to look at an application of exponential equations and using logarithms to solve them. This comes from section 5.7 in your book. These should be problems that you saw in Algebra 2 last year. The first topic is compound interest. Compound interest is when interest due at the end of each payment period is added to the principal so that the interest computed at the end of the next payment period is based on the new principal amount. Compound interest situations are where you earn interest on your interest. So the variables that we have here, capital P is your principal. That's the total amount borrowed. You may borrow, as an individual, may borrow money from your bank, or if you put money in a bank account, the bank is borrowing that money from you and is going to pay you interest on it. Lowercase r is the per annum interest rate, the yearly rate. This is sometimes called APR, annual percentage rate. When you plug an interest rate into any of these equations, it must be written as a decimal. So for example, 8%, we would write as 0.08 and so on. Capital A is future value. That's the amount of money you have after 2 years. So you start with your principal and you end up with your future value. And N is the number of compounding periods per year and will vary in each of the problems. For example, if we are annually compounding, we can simplify this formula a bit because annually compounding means 1 time per year, the N is 1. So the formula would say future value equals the principal times 1 plus the rate divided by 1, or just 1 plus the rate, raised to the 1 times t. T has to be the number of years. If it's monthly compounding, that's 12 times a year. So our formula says future value equals principal times 1 plus the rate divided by 12 raised to the 12t. Here, the exponent is 12 times as much. You're compounding 12 times as many times, but you're only getting 1/12 of the rate each time. Daily, we're going to ignore leap year and assume that there's 365 days in a year. So our future value is the principal times 1 plus the APR divided by 365 raised to the 365t. The exponent should be the total number of compounding periods. For example, if we want to find the amount that results is our future value. When we invest $50, that's our principal, how much we're investing, at 6%, that's our APR, compounded monthly. For compounding monthly, our N is 12 after a period of 3 years. That's our T. For these problems, I'm going to ask that you show how everything plugs into the formula, and then you're going to go to your calculator for the work. So A is principal times 1 plus my rate divided by 12, in this case, 6% is 0.06 divided by 12 times per year, raised to the 12 times 3. You should go to your calculator. You can type all of this in one step in your calculator, and we get that the future value, which is in dollars, so we're going to go the nearest cent, is $59.83. I would recommend checking that one, put in your calculator, make sure that's the number you get. We can also solve for how long it'll take an investment to grow up to a certain amount. So if we're solving for how long, we're trying to find the time. This is an investment of $1,200. That's your principal. That's growing to $1,500. That's your future value. Your rate is 3%, so is 0.03. And compounding annually means our N is going to be 1. So we have future value equals principal times 1 plus the rate divided by N, so 0.03 divided by 1 is still 0.03. And my exponent is t times the N. In this case, N is 1, so my exponent is just t. This is an exponential equation like you solved in the homework for the last couple nights. We need to solve for the exponent. You can do this algebraically or you can do it graphically. If you do it algebraically, remember that the first step has to be to divide both sides by 1200. This cancels. I have 15 over 12, which I can divide them both by 3. That's 5/4. You can change it to a decimal if you want. Equals 1.003 to the t. And then you have the option of either taking the log of both sides and pulling the t out front. So that you can then divide both sides by log of 1.003. And put all of this in your calculator. Or back here where we had the exponential equation, you can change that to log form. Log base 1.003 of 5/4 equals t. And then you can put that in your calculator. Either way, when you solve this one, let's go to the nearest hundredth, you should get 7.54 years. These problems can also be solved graphically by putting the future value, the 1500, into y1, and then putting the other side of the equation, 1200 times 1 plus 0.03 to the t, into y2 and looking for the point of intersection. Just make sure you can find a window that fits everything. There is one more equation that you're going to use today, and that's when you have continually compounded interest. This is where we're compounding almost instantaneously. You increase the number of compounding periods to infinity. And this is where that number e shows up in our work. E, remember this, is the constant that is the base of the natural logarithm. And again, there's a button on your calculator. It's about equal to 2.71828. When you have continuously compounding interest or continually compounding interest, you use a different formula. A is still future value, P is principal, but now we see the number E raised to the R times T as your exponent. There's no N in the formula because N is infinity. So if we want to find the amount that results from investing a principal of $1,000, so we're going to find A, if our principal is 1,000 at a rate of 10%, so our R is 0.1. Continuously compounded for 1 year. 1 year means t is 1. So the formula is principal times e, and my exponent is 0.1 times 1. And if I put all of that in my calculator, I should get 1105.17. It was 10% compounding interest, but after 1 year, we've actually earned 10.517% on that original $1,000. The more often that something compounds, the higher amount of interest that you will end up earning over that year. Same problem, but we want to find 18 months. Just remember that t has to be in years. So when I plug this in, my exponent is the rate times the number of years. 18 months is 1.5 years. And then I would put that in my calculator and I get 1181.63. There's a worksheet with problems for you to work through, and I would ask that you submit that by the end of the day on Friday, since there's no class tomorrow.